rating Benchy's first layer problems, printers oozing, and wait, glow in the dark is actually abrasive, all that and more on Print Fail Friday, episode 16. Let's get into it. Hey, thanks for joining us again on Print Fail Friday. If you haven't seen this series before, we're going to card to the entire series right up there so you guys can go take a watch at the entire playlist for Print Fail Friday. There are a lot of interesting fails and hopefully interesting ways to solve them as well. But let's jump right into this first fail. It says, rate my Benchy. Initial look might say, oh, okay, first layer's kind of crap. We can fix that. That's okay. And as you can see, even the cat is interested. She loves going through fails, but this looks like some maybe issues with retraction or lack thereof. This side actually looks okay, so maybe a cooling problem. But then we look at that. And, that ain't right. That ain't right. So let's kind of dissect what's going on here. We've got a first layer that's not right. So your first thing is to get that first layer closer, right? It's way too far away right now. We got to get that thing closer, because if we don't get it closer, you're not going to have good bed adhesion, and bad bed adhesion can lead to a bunch of other problems in the future. We're actually going to be taking a look at a solution to bed adhesion, so make sure you guys stay tuned for that. But what we also have is a cooling issue. Let's see. It's a silk PLA, which we knew. Okay, it's a Prusa Mini. Wait, what? This is not right for a Mini. This Mini was certainly not assembled correctly, because we have a loose belt. So if you don't have something that's circular, and it's supposed to be circular, the top of a Benchy for reference, the top of a Benchy is supposed to be circular. Now, this is not a perfect Benchy. I can definitely go into the things that are done wrong here, but this one was also time-lapse, so it's a little bit different. The top of this is supposed to be dead circular, and we don't have that here. That tells me that we've got a loose belt. Now, if I'm correct, the Benchy prints like this. The belt is loose in the X direction, I think. Your belts are definitely loose, though. We've definitely got a problem there. Like, everything is off. There's a lot wrong with this. But yeah, belts are going to be really, really loose here. And I think that's going to be most of the problem. Because if the machine is not moving appropriately when it's retracting, you're going to get these problems. So I have a feeling either the belts are loose or the actual pinion gear that's on the motor is loose. So the belts could be tight, but the gear on the motor is loose, which is causing some backlash in that movement. But yeah, to be honest, I didn't expect this from a Prusa. I think this is all done in the assembly process. And I've seen the Minis have problems, like to the point where we made a whole video on how to keep your Prusa Mini running effectively. We'll card to that video so you guys can take a look at it. But this is really rough Benchy. Like, I would expect this out of like a bone stock ANET A8. Like a $100 Housefire, not a $450 Prusa. So I'm going to reach out to this user, make sure that we can get this thing solved for them as well. But the one thing that we're never going to solve? My segue to our sponsor, 3D Musketeers. If you want to get your ideas out of your head and into your hands with full art-to-part rapid prototyping and product development, you can reach out to the experts over at 3D Musketeers. We have over 30 printers to help you reduce chances of failure like this, because we recognize that a lot of times 3D printing can kind of be a pain in the ass, and that's okay. It's why we have a bunch of printers to help you get the products you need done when you need them done. Fails like this don't happen all the time, especially on Prusas, but they're not uncommon, and the experts at 3DM understand this. Let us utilize our over 30 years of combined experience to make your 3D printing a breeze. can reach out to us. Links will be in the description. If you want to support us directly, you can do so at patreon.com/3D Musketeers, with tiers starting as low as $1 freaking dollar. We're going to have YouTube channel memberships coming up soon, so stay tuned for that. Our graphic designer is working on all the custom emoji stickers and crap, so excited for that. Anyways, let's get back to the fails. Why does my Ender 3 V2 ooze filament constantly when heated? I've been having a ton of issues with this printer. My prints keep failing when the filament loses connection with the bed and gets stuck to the nozzle instead. I think it has something to do with the fact that my printer will ooze continuously whenever it is heated up. I run PLA at 205 degrees usually, but it oozes even at 180. I just cleaned out the hot end with some nylon cold pulls, tightened everything on the hot end down, and replaced the nozzle, and this is still happening. I replaced the extruder to be all metal, and I've upgraded the tubing as well. I'm starting to be at a loss for what to do to fix this. This is the kind of frustration about the Ender platform. If you don't know that Bowdens and most 3D printers will naturally ooze, and especially Bowdens, the reason that Bowden printers tend to ooze is that you have between your extruder and your hot end a piece of Bowden tube. That Bowden tube is not exactly the same diameter as your filament. It can't easily be. And because of this, it has backlash. And so when you're feeding filament through, you're actually putting some pressure, some back pressure into that tube. So when you stop extruding, it will ooze. This even happens on direct drives because guess what? You're not putting it right from the extruder right into the hot zone. It has to go through a heat sink. So there even is some oozing associated with direct drive printers. This is normal. If your printer is oozing when it heats up, that's fine. Don't worry about it. But if your prints are failing when the filament loses connection with the bed and gets stuck to the nozzle, as we see here, that has got nothing to do with oozing. That has everything to do with your first layer adhesion. One of the big things that you can do is make sure that your bed is clean. I want to see it cleaned with alcohol and then with dish soap. I want to see this thing squeaky freaking clean so that we can remove the bed as one of the potential problems. It's kind of an issue on these weird glass beds that Creality uses, that all of a sudden they just stop sticking. It's why we recommend going to a flex plate. We're going to be doing an entire series on upgrading our Ender 3 piece by piece by piece to actually make it a venerable 3D printer that shouldn't have issues like this. So get subscribed and leave a like if you're excited for something like that. This unfortunately has a correlation, but it does not equal causation. Oozing can create print failures. It's one of the big reasons that print failures do occur. However, it is not the reason that print failures occur. So it's kind of odd in that way, but it is all about making sure that first layer is good. So you want to make sure you get a nice even glass first layer, and that is looking at the top of your first layer. If you run your finger over it, you don't want to feel any ridges. It needs to be as smooth as glass, and that's how you know, at least on an Ender 3, that you got a nice, clean, good first layer. If it's bumpy at all, either positive or negative, you've got a problem and you need to adjust your bed accordingly. If you feel ridges, like peaks, you're too close, move your nozzle away. If you feel divots, so where it's like this, you need to bring your nozzle closer, which will then bring the layers themselves closer as well. PLA at 205 to 180 is absolutely fine. Actually, the print that just finished behind me ran at 180, and hilariously, that is part of an upcoming failure. Yeah, Grant's got a failure this week too, so stay tuned for that. Replacing the extruder to all metal, upgrading the tubing, new nozzle, tightened everything, cold pulls. Those are all good things to do, but they're not going to solve the problem of bad bed adhesion. If you're still having bad bed adhesion, look at putting something like glue or hairspray on it, or just look at completely replacing that glass bed with something like a magnetic flex plate from Wham Bam or a generic one. We'll have links to a couple down in that description for you, so you guys can take a look at some if you're looking to get one. Now, I will say, I do somewhat recommend to put the flex plate right on the piece of glass from the Ender 3, because a lot of times their aluminum build plate underneath the glass is not very flat. So be cautioned about that. Now, you can also go ahead and get a piece of glass cut at a local glassmaker for pretty cheap. Make sure you get tempered, and if you can, borosilicate is the proper glass to get, also known as Pyrex. The industry name is Pyrex, but the technical name is borosilicate. Borosilicate can withstand temperature fluctuations, which is why Pyrex is as good as it is. Normal plate glass, if it's hot and you spray it with like water, it'll crack on you. Tempered glass is under stress all the time, and when it breaks, it just shatters into a billion pieces. But the trick with tempered glass is it's not normally sharp when it shatters. So if you want to go a little bit cheaper, go minimally with tempered glass. Don't play with the plate glass. It's kind of dangerous. And here, right here, is what this is all about. A full day of bed adhesion pain cured by washing in the sink with soap. A lot of times alcohol is not the right answer. It can be, but you have to make sure that you're physically handling the build plate appropriately. If you're touching it with your grubby, nasty fingers, you're gonna, no matter how you clean it, if you're touching it, when you're putting it back onto the printer, you're gonna have problems. Now, see, she knows. You want to treat it like you would treat a vinyl record. Hold it from the sides. Don't touch the top or the bottom because you can dirty it that way. Soap and water is a great way, especially dish soap. Really hot water where you can, as much as you can generally suffer. Don't burn yourself, please. But that is what can really make this stuff better. When it comes to bed adhesion, if you don't have good bed adhesion, nothing else matters. It's like Metallica. Literally nothing else matters if your bed adhesion sucks. Nothing else matters. I don't care if you can make prints as nice as some of the best 3D printers on the planet. If your first layer sucks, the rest of it is going to have problems too, generally speaking. So dial in that first layer. Make sure your bed is cleaned with soap and water. Make sure you're holding it from the edges so you're not touching it and getting oil all over it from your hands. And make sure that Z offset is set correctly, and you'll probably not have a bad time. This seam is really stringy and blobby. No matter what I change, it keeps happening. Settings included on other slides. Okay. Oh. Jeez. Alright, you're doing 0.07 millimeter layer height. The line width should be larger than the diameter of your nozzle, so you will want to use like a 0.45. That's not going to cause your problems though. Wall thickness of 0.8. That's fine. Wall count of 2. So far, we're fine. Infill density of 100%. That can cause a problem. So if you're trying to make something dead solid, do not use infill 100%. Put infill at your regular level and put 1,000 top and 1,000 bottom layers. Infill a lot of times is deliberately over extruded to make your parts stronger. Now, I don't believe that's set here in Cura. Yeah, it's set to be normal. But if your printer is even mildly over extruding, you've got yourself a problem because it's going to quickly do additive error and get worse and worse and worse. A 30% overlap is a little larger than I'd like to see personally. 22 to 25 is normally where we keep our percentage for overlap. Otherwise, that's okay. Print speed. Now, I don't know what printer this is. Okay, it's an Ender 3. Ender 3s cannot run this fast. Now, you're running a 0.07 millimeter layer. Technically they can. Their kinematics don't allow them to run that fast reliably. Now, if you tighten everything up, make sure the V wheels are perfectly tensioned, maybe then you'll be okay. Travel speed at 250 is gonna likely be a little bit high. Initial speed of 20 and skirt brim of 20 is all fine as well. Now, they're likely not going over their volumetric flow rate. We're gonna have a whole video on that coming soon, but they're likely not going over that. The volumetric flow rate, TLDR, is how much material you can feed through your hot end and have it adequately heat. If you go above that number, which is normally millimeters cubed per second, If you go above that number, the hot end will not be able to fully heat everything, and you're not going to get proper printing. You're going to either get a lot of die swell, or it's going to physically start to jam or under extrude. Stefan of CNC Kitchen actually did a great write-up about this when he's doing his CHT nozzle review. We'll card to that video so you guys can go take a look at it. It's a really good video, and if you don't know about CNC Kitchen, Stefan does amazing videos, so go give him the credit he deserves there as well. Not that he needs it. I think he's like well over 800,000 subscribers. But I feel like if you found us, you probably know him. Anyways, retraction of 4mm. I mean, there's your problem. I want that up. Like, those are rookie numbers. You got to pump those numbers up. I want to see probably 5 or 6. But the problem is, you are dealing with such small layers here. Like, one, there's no friggin' reason to be running layers that thin on parts like this. Run 0.2, it'll be fine. But that kind of retraction, you're not feeding a ton of filament. Like, you're literally getting into where micro stepping becomes a problem. 1/128th micro stepping becomes a problem. You need to go to 1/256th or 1/512th, and that is generally well beyond the limitation of stock 1.8 degree stepper motors. We're gonna have a whole video coming up about, like, printer terminology, because there's a lot of newbies out there, and I really want to make sure that everybody has a good experience in this industry. This kind of stuff can be really frustrating. But I firmly believe that if you don't need to run layers of 0.07mm, don't. Run 0.2. It's what those nozzles were designed for. Go ahead and increase your line width to 0.45. You can have your outer wall be 0.4, but what we normally do is 0.45 everywhere, and then the infill is 0.5. Give it a little bit of extra meat and potatoes there for it to grab onto. But everything else is pretty standard. I mean, wall thickness would then go up to 0.9, but everything else here is relatively standard. I don't like the infill density, and I think the speed is way too damn fast, simply for the kinematics of the Ender 3. But I think a lot of that will get worked out once we solve this issue with the really thin layers. I'm curious to see if anybody else went through this. He said, I did some messing around and got the stringing to go away. Now it's just really rough layers. I do 0.07 when I want something really smooth, and it usually works fine. I have been using 0.2 on the tests though. So if you've been testing with 0.2, but you normally print with 0.07, slight over extrusion will be a massive problem at 0.07. The other thing to point out here is your top and bottom layers. With 0.07, you're going to have a problem if you only have like 5 top layers. So you want to make sure that your top and bottom layers are set to a thickness and not an amount of layers. PruSlicer has a beautiful integration here where they let you choose both the amount of layers as well as the minimum thickness, which I think is really, really cool. So you could say, I want it to be 5 layers thick, but a minimum of 1.2 or whatever it might be. And I really like that feature that they implement. This can be frustrating though, because again, small amounts of over extrusion are going to be very obvious at 0.07, where 0.2, you're not going to see it. And I just missed this part. So this is why putting some of this in your settings is really important. You're not running a stock Ender 3. And now when I told you about retraction, is not actually all that valid anymore. I would look at retraction of, like, if it's a physical direct drive, like 0.8 at 65. Combing with an infill is fine. Don't worry about avoiding the printed parts when traveling. That does not matter. Avoid, and you can, yeah, I would turn those two off. This might have something to do with it, because if it's going to avoid the printed part when traveling, it's actually going to follow the perimeter of the part, potentially oozing as it does that, leaving those little blobs. I'd be more curious to look into that than I would be over extrusion. Try that first. But if you didn't set your steps per millimeter when you went to a direct drive setup, hey, you're going to have a problem. You really need to tune in your steps per millimeter every single time you make an extruder change. Like, it really does just need to be done. And we have a Z-hop, but I can't see what it is. Z-hop of at least 0.4 is good. I do 0.6. I'd rather be safe than sorry. We got one from our buddies over at Kiersey Fabrications. Day after Christmas fail, don't worry, it's printing great now. It's a Spider-Man No Way Home 3D print, and this is apparently what it's supposed to look like. So we can see some things here. One, this is all caused by layer skipping. We can see actually down here that we had some shifting. Now, likely, we had either a cooling problem, maybe some support broke and got in the way and caused the nozzle to grab it and actually skip a step or two. And it looks like we have some left-right shifting here. And then as it got higher up, it got way worse. You can actually see the shift was quite large, and it caused the entire print to fail. We can see back here that it was printing in air for a while. Ultimately, of course, it's just about resetting the print and moving on. But this kind of stuff does suck when you are still starting. I believe this is a Creality printer. The glass bed screams Creality, but some of the other stuff doesn't. I don't know. I can't immediately figure out what the printer is from just looking at it. But yeah, it looks like they're using Prusa Slicer, or these are actually rafts. And if they're rafts, poo-poo. Don't use rafts, kids. They're antiquated. Please don't use rafts. But yeah, lots of support material, and the print itself is a pretty complex piece. So your chances of failure are pretty high when you're trying to print it to get the best detail, which might not be flat on the build plate. You might want to angle it at like 45 degrees or something, where you'll get better print quality as long as you can get it to stick to the bed. So maybe it came off the bed here. Great way to solve this. If you like it, then you should put a brim on it. And speaking of, let's look at one of my fails. I've got a plate of neon green mom's spaghetti here, and this is actually from the Alien 3D November box. We just started the Alien 3D Maker box, and we're gonna have a video coming up on it here shortly, where we actually build it. You can actually see, there's part of it behind me. It's a digital hourglass, and the parts on this printer just finished that are going to it as well. I screwed up here. I didn't put a brim on it, and I thought it was going to be okay. And the cool part is it's time-lapsed. So I'm going to have the time-lapse right here, and this will be Tuesday's time-lapse of next week. So you guys can see that a little early. But yeah, this was a bummer. So, of course, I left it running overnight, as I do, because I don't stay up 24 hours a day. But, yeah, woke up to the big plate, and it wasn't until I looked at the photos that I realized that this piece was actually behind the printer. So in a couple of time lapses, this is back there. I don't know if the camera picks it up, but I didn't notice it. I thought it got failed like this. But what we can see is that it knocked this green part off, and then it just started trying to print on these bigger blobs, and then eventually just made a big plate of spaghetti. Bit of a bummer there, unfortunately. But it happens, right? The second print, I put a brim on it, and it came out great. You can kind of see the blue part on the back there. It's that hourglass back shape, not the green piece. That was the part that actually succeeded. But yeah, we're going to be doing an entire time-lapse of the Alien 3D box and then a build video on it as well, because it is a pretty cool project, and I think maybe you guys will like them. Who knows? Great way to solve that, put a brim on it. The time-lapse doesn't help either, right? If it didn't have a time-lapse, it might have been okay. But what occurs is the printer is printing, it stops, the head moves out of the way, and the camera then takes the photo, and then the head moves back. During that movement process, it likely oozed a little bit, grabbed the edge of the part, and ripped it off the build. When we added a 5mm brim, it stuck like friggin' glue, and we did not have any issues at all. You grab a deburring tool, and you can quickly clean off the brims. So it makes life a little bit easier. I didn't listen to my own damn statement, so I guess this is a do as I say, not as I do thing. If you like it, then you should put a brim on it. And last but certainly not least, glow-in-the-dark can do some damage, LOL. I've said it. I've said it. And so many manufacturers completely ignore the fact that glow-in-the-dark filament is abrasive. One other thing to note is your thumb screw touching your lead screw? Because it looks like it is. If it is, take that off. It's crazy abrasive. And if you're running a brass nozzle, if it did this to your extruder, imagine what it's doing to your brass nozzle. Glow in the Dark uses a mica powder, silica, basically, to make this happen. And that is glass. It's abrasive. And it's really, really harmful to your printers. We actually replaced one of these extruder styles on the Ender 3 Pro that we had in from a client. We'll card that video so you guys can take a look at it, with one that had Bowden tube on both sides, and that would enable this glow-in-the-dark material to come in without contacting the metal. I've never liked this setup where the filament just goes through, because even if you're not using something like an abrasive filament like glow-in-the-dark, it's still over time going to wear through. So what do you do in this case? Well, the user is using hardened steel nozzles, so their nozzle is likely fine. Their extruder drive gear, though, I'd like to point out is clearly damaged. So they're using a brass extruder gear when they should be using hardened steel as well. Because guess what? It causes issues all over the place. They have a 16 printer farm, but this is very much something that you should know better if you're doing this on a professional level. Glow in the dark is crazy dangerous, and this is costing you not just parts, because parts have some expense to them, but more importantly, it's costing you time. I also think that this is touching your lead screws, so could be a problem. But either way, brand new extruder, like there's really no way to fix this. How do you solve it? You don't let it happen in the first place. And not the greatest solution to the problem, but it does work, right? It's one of those, it's not ideal, but it gets the job done kind of solutions. And then the other thing is, don't print glow-in-the-dark filament. Just paint your parts glow-in-the-dark. Use mica powder like everybody else does. It's better anyways. Yes, glow-in-the-dark filament is really cool because the glow emanates from the internal structures of the part, but if you can't get UV light to penetrate that deep anyways, it doesn't freaking matter what your name is, jabroni. You get where I'm going with this. Abrasive filaments like glow-in-the-dark, carbon fibers, glass fibers, and anything that has an additive to it. Technically, even wood fill is mildly abrasive. Like, nowhere near this bad, but I mean, over time, it will cause some abrasion. You have to look at your nozzles, your extruder, idler stuff as consumable parts. We actually replaced the top cover to the Prusa extruder once every quarter just to keep up with the fact that they wear through over time, and we don't print a lot of abrasives on our Prusas. We have dedicated abrasives printers just for that purpose. But I feel for this because there's metal flakes now all through your entire extruder process. You got to rip apart your entire extruder system and completely clean it out. Quite frankly, I'd be taking it apart, I'd be throwing it away as a business, and putting in a brand new piece and just starting from scratch, because there's been a lot of damage that's occurred here and it's way too late to fix it. And I think the remedy of trying to clean it is more work than it's worth. When you're running 16 printers like this person, you know, according to their Flare is running 16 printers, you really have to look at what your time is worth to you. That's really all I got for you guys today here on Print Fail Friday, episode 16. Let me know in those comments, do you like Print Fail Friday? They actually haven't been performing as well as they used to, so I don't know if that's like y'all are getting tired of it or what might be going on. Let me know down in the comments as well. Did I do well? The one that's still kind of confusing me is the one from the Prusa Mini. It's clearly a belt issue, but I really don't know, like, I want to get the belt issue solved and then live adjust Z and then see how it does, because I think maybe that would be okay. I don't know. I don't know. Anyways, I want to make content that you guys like and content that we enjoy. I love making Print Fail Friday because it forces me to learn and look at these failures from the perspective of other users. And we recognize there are so many new users right now, and you're likely, potentially, if you are a new user, finding this video because you had a failure that we mentioned in this video. So hopefully this helped you out, and if it did, leave a like and get subscribed. We would greatly appreciate it. But anyways, guys, stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one. If you like it, then you should put a brim on it. Because otherwise, it's going to be oh. Grant, these jokes are bad. And you know they're bad. Hey, thanks so much for watching this video. And if you like fails, make sure you leave a like. And I want to give a special, massive thank you to all of our patrons. Thank you guys for everything that you are doing to make this channel go forward. If you want us to support us directly, you can do so at patreon.com/3D Musketeers. And YouTube channel memberships are coming very soon. But at the $5 tier and higher over on Patreon, the names of all of those patrons are listed right next to me. Thank you guys for everything that you do. Right below me will be the entire PrintFailFriday series, so that if you want to go back and take a look at some of the other ones from weeks past, you can do so as well. And right next to that will be the entire printer maintenance series. So if you got a brand new printer, you want to learn how to maintain it, we generally cover the big few printers out there, and you can adapt it likely to fit yours. I will see you guys down in those comments, and in the next one, take care.